So several of you had issues with this homework assignment in 5.2, and so I want to go over this a little bit. I'm not doing the whole homework, but I'm doing this to kind of help you out, make sure you're understanding this. So we're going to start with number 9. We're going to use the 68, 95, 99.7 rule, and we're testing a test of depth perception is designed so that scores are normally distributed with a mean of 50 and a standard deviation of 10. So the mean of 50 and the standard deviation of 10, those are the key things we need to know. We're going to use the rule to find the following values. So to recap on the rule, this is 68 is 1 standard deviation. 68% of the data falls within 1 standard deviation of the mean. 95% of the data falls within 2 standard deviations, and 99.7 falls within 3 standard deviations of the mean. So I think a picture is worth 1,000 words. So in this case, I'm going to kind of sketch this out. So this is just a normal distribution of a graph. In the center here, we will have our mean. If it's normally distributed, the mean will be in the center. Standard deviation of 10. That means this will be 60. This would be 70. This will be 80. On this end, we'll have 40, 30, and 20. So this means that from here to here, that's 68% of our data falls in that first standard deviation. The second standard deviations on either side of the mean, that is going to be our 95% of our data. And then the third one, where it's 3 standard deviations, that is our 99.7%. So 1 standard deviation on either side, 2 standard deviations on either side of the mean, and then 3. Those are what we're using. So we're looking at the percentage of scores less than 50. So understand with the normal distribution, half of our data is above the mean and half of it is below. So if we're looking at the percentage of scores less than 50, well, that means less than 50, that's 50% of the data or the scores. 50% of the scores are below the mean. The percentage of scores that are less than 60. So we're looking at from 60 and below, well, less than 60, so 59. But we need to understand that the data that falls right here between 40 and 60, that's 68% of the data. Well, that means that half of it's on this side, half of it's on that side. So if we take our 68% and divide by 2, we end up with 34%. Why we need that is the data that's between right here, between the 50 and 60, that's the part we need to know. We know that this part here is 50%. From 50 and below, it's 50. So we need to know the percentage of data or scores that are landing between 50 and 60. So if we use that 68% is right in that group, that means 34%, half of it is on the left side and half of it's on the right. So that means this part right here is 34%. So if I take the 34% and then I add the 50%, so that's this 34 and then the 50 is that way, we will get 84% of our scores are less than 60. The third part, Part C, the percentage of scores greater than 70. Well, now we understand greater than 70, between 30 and 70, it is 95%. So if we're looking at, let me make sure, 95% of our data lands here. So that means if we have this part right here, and let's do 2 fingers. If that part right there covered up is the 95%, then that means this part and this part is going to be a total of 5 left, because 100% of our scores, 95% of them are landing right there. So that means part of it's here and part of it's there. So if we take 100, so 100%, and we subtract out 95%, it leaves us with 5% of our data, or our scores. Same thing. So that means 5% in total between 30 and 70 there. 5% covers both sides. Well, again, we're looking for the part that's on the top side. So we're going to take the 5% and divide by 2, and it gets us 2.5%. So that means 2.5% is up here and 2.5% is down there. Now, the percentage of scores greater than 40. So we did part of this already, because remember, between 40 and 60 is our 68%. 68%, that means there's 34% here and 34% here. We're looking for greater than 40, so that means that 50 and above, that's 50%. We've covered that before. Now this is 34%, so we have our 50% plus our 34% gets us 84%. Now, our next question says percentage of scores between 40 and 70. So we know that 68% lands here, but we need to know this portion here. From 40 to 60 is 68%, but we need to know the portion between 60 and 70. So for this, we know that this whole section of red is the 95%. However, we don't need the entire part. We need this to this. So we need to not have this part, but we need to have that part. So if we take our 95%, that's the red line, and we subtract out our blue line here of 68%, we end up with 27%. So that means for the the second standard deviation there from the mean, that red line, if we take out the blue part right here, so if we take out the blue, that means there's 27% from this part and that part. So what are we going to do? Let's divide it by 2. So 27% divided by 2, that'll get us 13.5%. So that means 13.5 is here and 13.5 is there. So that means we can take our 68% from 40 to 60, add the 13.5. So we're going to take our 68 plus our 13.5, and that will get us a total of 81.5%. So you're still using the rule, but you're going to have to do a little bit of interpretation on it. You're going to have to think about it to figure out what some of it is going on. So the next problem is going to be very similar, but slightly different, maybe in slightly different order. So let's go look at this one, because I want to make sure that you have a good understanding of it. All right, so here's our next one. We're going to have another standard graph. And this will be our center at our mean. We have pulse rates for adult females are normally distributed with a mean of 74 beats per minute and a standard deviation of 12.5. We're going to use that rule again. So that means our mean is at 74 and each standard deviation is 12.5. So if 12.5 plus 74 will get us 86.5. Another standard deviation, when we add 12.5 to that, we get 99. Plus another standard deviation will get us 111.5. Going the other direction, we're going to subtract 12.5, and when we do that, we get 61.5. And then we'll subtract it again, and we will end up with 49. And we're not quite superly spaced, but it'll be all right. And then our last one would be 36.5. So all I'm doing is taking the mean again, and I'm adding my standard deviation, and I'm subtracting my standard deviation. So the percentage of pulse rates that are less than 74. Well, this is very similar to part A on our previous problem. 74 and less than that, that's going to be 50% of our data again. Because remember, it is symmetrical. Half of the data is there, half of the data is at the bottom. All right, let's go look at another problem with it. Scoot up just a little bit. The percentage of repulse rates between 49 and 99. So 49, that's 2 standard deviations away from the mean, and 99 is 2 standard deviations away from the mean. So because it's 2 standard deviations away, how much of our data is in that thing? So we didn't draw our deals here, so let's do, here's our blue one. And then we had our red one. And then we've got the black one. So the blue one is our 68%. And our red one is our 95%. And then the black one is our 99.7%. All right, so we're looking from 49 to 99. Well, that's 2 standard deviations on either side. So we know that that's going to be 95% of our data because it's within 2 standard deviations. All right, the percentage of pulse rates between 61.5 and 86.5. Well, that is our 68%. That's our 1 standard deviation on either side, so it's 86%. The percentage of pulse rates between 36.5 and 111.5. Well, that's our 99.7 because that's 1, 2, 3, and 1, 2, 3 standard deviations away from the mean. So 99.7%. Now it's asking us to find the pulse rates greater than 99. Well, we know that between 49 and 99, that's 95% of our data. So again, we're looking at 100 minus the 95% of the data gets us 5%. And of that 5%, half of it's on this side and half of it's on this side. We're only looking for the greater than. So we'll take our 5%, divide by 2, and we get 2.5%. So if you can draw out your curve in your graph and figure out the standard deviation marks, it makes it way easier to understand what's going on with our problems. So I'm hoping that this kind of helps you understand a little bit more of what you need to do as far as looking at if it's using this rule, it has to be normally distributed. And then we're looking at making, if we can draw the graph out a little bit, it makes a little more sense on what to do. I hope this helps you understand the homework assignment a little bit better, and that way you can understand it a little bit better even for the exam.